Alright, let's do a problem. An infinite plane of surface charge density sigma equal to 4.5 Newton nanocoulomb per meter squared lies in the YZ plane, and a second infinite plane of surface charge density negative 4.5 nanocoulomb per meter squared lies in the plane parallel to the YZ plane at x equal to 2 meter. Find the electric field at x equal to 1.8 meter, at x equal to 5 meter. Well, we have two plane surfaces like this, and each is in the YZ plane. In other words, it is vertical. Let's draw a diagram of that. Now, this is the first infinite plane in the YZ plane. Look at this, x-axis, y-axis, z-axis. So the vertical plane is the YZ plane. The surface charge density on this is sigma, and on the second one is negative sigma. Is that right? The surface charge density on the first plane is positive 4.5 nanocoulomb per meter square. On the other one, it is negative 4.5 nanocoulomb per meter square. Now the field lines start at the positive and go towards the negative. So the electric field lines between these two planes will be like this. They will start at the positive and end at the negative. Alright? In the space between the two planes, the field due to the positive plane is in the same direction as the field due to the negative plane. Why? The direction of the electric field is the direction in which a positive test charge will move. If you place a positive test charge here, it will move away from the positive and towards the negative. That means the electric field in between the two planes will be the same direction due to both these charges. The electric field due to the positive charge will be directed away from it, and the electric field due to the negative charges will be directed towards it. And that means the electric field between these two planes will be represented by parallel field lines. The field will be uniform anywhere here. You see, the electric field will have the same value at any point in between these two planes. And you can find that using Gauss's law. Now, between the two planes, these two fields add up. That means the field due to this plane will add up to the field due to the second plane. Now, what is the electric field at a point due to an infinite plane? The field near an infinite plane charge is, you remember that we just derived the equation, is sigma over 2 epsilon naught. E equal to sigma over 2 epsilon naught. So, if you take a point here, the electric field at this point due to the positive plane charge will be sigma over 2 epsilon naught. The field at that point due to the negatively charged plane also will be sigma over 2 epsilon naught, and they are both in the same direction. That means they will add up to produce a net field. The field at any point between the two plates therefore is sigma over 2 epsilon naught, that is due to the positive plate, plus sigma over 2 epsilon naught, that is due to the negatively charged plane. They are both in the same direction, therefore they add together to give you the net field at that point. What is that equal to? sigma over epsilon naught. And now that is a very important result. Very often we will consider this. If you have two plane charges like this that are kept very close to each other, what is the electric field at any point in between? The electric field at any point in between is sigma over epsilon naught, where sigma is the charge density at either of these plates. But remember, in such a case, one is positively charged, the other is negatively charged. Otherwise, this will not be true. If two plane charges, one positively charged and the other negatively charged, are kept close to each other, then the field in between, the field at any point in between, will be given by sigma over epsilon naught. Okay, I will ask you this a little while later, and I suppose you will then remember this. Okay. Therefore, the field at x equal to 1.8. Now, what is the distance between these two planes? Well, the distance between the two planes is 2 meters, because the first plane is at the origin and the second plane is at x equal to 2 meters, and therefore we need to find the electric field at x equal to 1.8 meters. Where is that point? X equal to 1.8 is inside the two plane surfaces. That means the field at that point will be sigma over epsilon naught, and sigma is 4.5 times 10 to the negative 9, and epsilon naught, well, we have been using that value, 8.85 times 10 to the negative 12. Therefore, the field at that point is 508.5 Newton per Coulomb. In fact, you can take any point in between. The field at x equal to 1 meter will be this. The field at x equal to 0.5 meter will be this. The electric field at x equal to 1.9 meter will be this. The field at any point in between these plane charges will be this, because the field in between is uniform and is the same at all points in between the two plane charges. Okay, so we did A. How about B? Field at x equal to 5 meter. We need to find the field outside of this negative plane. Find the electric field at x equal to 5 meter. Well, to the left of the positive plate, the field due to the positive plate will be in that direction. Is that right? Now these red lines represent so the electric field on the left of the positively charged plane will be directed to the left. Now, in this region, there will be also a field produced by the negatively charged plane. What will be the direction of those field lines? You see, the field lines are directed away from a positive charge and directed towards a negative charge. That means in this region that is to the left of the positively charged plane, the electric field due to the positive charge will be directed away from it, and the electric field due to this negative charge will be directed towards it, and that will be these green lines. That means what will be the sum of these two fields? They will cancel each other. There will be no net field outside to the left side. So to the left of the positive plate, the field due to the positive plate, that is these red field lines, is in the opposite direction as the field due to the negative plate, they cancel each other. That means there is no net field to the left of the positive plate. How about to the right of the negative plate? A similar situation exists. To the left of the negative plate, the field due to the negative plates are these green field lines. And the field due to the positive will be the red field lines. Again, they will cancel each other. The field due to the positive plate will cancel the field due to the negative. Therefore, there is no net field to the right of the negative plane. What that means is, if I have two infinitely large charged planes, one positive and the other negative, there will be no electric field to the left of this plate or to the right of the other plates. Electric field will exist only in between the two plates, and the field in between will be uniform and the same at all points. Alright, and therefore what is the field at x equal to 5? X equal to 5 is a point outside the two plane charges. Therefore that field will be equal to 0. There will be no electric field at points to the left of the positive plane and at points to the right of the negative plane. I hope that is clear. Field due to a spherical